Hi students, in this video we are going to discuss operations performed on binary heap. In previous video I have explained what is a binary heap and its properties. Now in this video we are going to discuss operations performed on binary heap. There are two operations. That means we can perform two operations performed on binary heap. What are they? One is insertion as usual. Second one is deletion. That is okay, but especially here we will call it as delete max or delete min. This also we can call it as find max or find min. So these are the two operations performed on binary heap. So let us start with the first operation, insertion operation. So what is meant by insertion operation? Insertion operation means what generally? Inserting an element. Which data structure here it is? Binary heap. So inserting an element into a binary heap is called as insertion. See, inserting an element. Inserting an element into the binary heap. Inserting an element into the binary heap is called as insertion operation. Now let us take an example how to perform insertion operation. So insert of some 6 I want to insert, and already the binary heap is like max heap. Okay, so it is in the form of max heap. Now for example, this is the binary 10, some 8, here it is 2, here it is 7, and here it is 5. So max heap, parent is greater than its children, parent is greater than its children, parent is greater than its children. Okay, so now see, I want to insert element 6. Okay, so now what we have to do is in the next position create a hole like this. Why? Because you are adding one element means extra space is required. Where we have to give the space, so that is a complete binary tree. What is the correct location? This is a correct location. So that's why we have to create the hole. So now what is the element you want to insert? 6 you want to insert. What is its parent? Parent is 2. Hole's parent is 2. Okay, compare this is 6 and 2. So 6 we have to actually place here. Why? Because it is max heap property. Okay, that's why 2 we will move downwards, then hole will be created here. So 10. This left side is as it is. We have to consider only right side. Why? Because hole is created on right side. 8, 7, 5. And here what will happen is, what will happen here? 2 will be moved to this whole position, and here hole is created. We can't directly insert 6 in this position as we don't know the correct position. So all that, why? Because this node is having another child, another parent. So that's why we have to consider this. Now what we have to do is compare 10 and 6. That means this hole's parent. Hole's parent is 10, compare 10 and 6. As 6 is less, insert that is 6 in this whole position. Now check is it max heap or not. Well, because we consider max heap now. So check is it max heap or not. Yes. So this is max heap. Now let us take example 2. Consider same max heap only. Max heap. And I want to perform insert of 20. I want to perform insert of 20. Okay, so now consider the binary heap like this. 30, 25, 20, here it is 18, here it is some like 16. Parent is greater than its children, na? So that's why 15, and here it is 12. And now I want to insert. Parent should be greater than its children. So I want to insert an element 40. Where can I insert? So this is tree level 0, this is level 1, this is level 2. Where the next element will be inserted? The next element will be inserted here. So here is the hole. Find out the hole's parent. 18. Compare this 18 and 40. As 40 is greater, na, then what we will do is 18 we will move to this whole position. Then the tree is 30. You will get changes only in this side. Why? Because that hole is created on left side. No need to consider this. This is as it is. Okay. So here it is 20, 20 left, 15, 20 right, 12. Okay. Then 25's left is the hole, 25's right, there is no change, and 18 is moved to its child position, which is nothing but whole position. Okay. So now find out this hole's parent, which is 25. Compare this 25 and this element. So as this is greater, then what we will do is, again we will move 25 to this whole position. What will happen then? So here hole will be created. Now let us see. So from here, 30 is as it is. Now here hole is created. For this, 25 is moved to this whole position. So 25, then here it is 16. And here it is 18, 20, 15, 12. Okay. Now hole is created here. We can't directly insert 40 here. Why? Because this hole is having, now this is the hole. No? This hole is having its parent. What is max heap? A parent should be greater. That's why again we have to compare this 30 and 40. As 40 is greater, then this 30 will be moved to this whole position. Now the tree is, here hole is created. Here it is 30, 20, 25, 16. These elements are as it is now, 12, and here it is 18. And this is a hole. Hole is nothing but a first position. That means it is not having any parent. Now in this hole, this element to be inserted. So that element will be inserted. 40. See Max-Heap property, 40 greater than 30, 20. 30 is greater than 25, 16. 20 is greater than 15, 12. So then 25 is greater than 18. Yes, after insertion, it is satisfying the Max-Heap property. So this is an insertion operation in a binary heap. Okay. So now next, second operation is, so we discussed max heap, na? So insertion we have done. Okay. So you can do by considering min heap also, no problem. But what you have to check is a parent is less than its children. That's it. Based on that, you move whole towards, see if you observe, whole is moving towards up direction. Whole is moving towards up direction. Okay, so this operation is called as percolate up. This percolate up is nothing but moving up. So if whole is moving towards up direction, So then that operation is called as percolate up operation, and this you will get while performing insertion operation. Okay, so this is insertion operation into a binary heap. In the next video, we are going to discuss delete min or delete max operations in a binary heap. Hope you understand, students. So please share with your friends if you understand the concept. Thank you, students. Have a great day. If you have not subscribed, don't forget to subscribe. So have a great day. Bye.